Okay, we're going to talk about measures of dispersion. The measures of central tendency were ways of telling what was typical or average. Measures of dispersion are to figure out how spread out things are, how much variance there is. Actually, the term variance refers to something very specific. So I should say how much variation. Okay. Now, when talking about class widths for histograms, we've already seen range is the maximum score minus the minimum score. We don't have to have things in order, but since we do, we can see that for this example, that's the highest score is 7, the lowest score is 1, and so this distribution has a range of 6. We have also already seen that the mean, which we found for this one, was total of 15 over 5 scores. We had a mean of 3. We have seen when mean was introduced that it levels out things when we take score minus mean in that order, score minus mean for each score, that it balances things out. So let's take a look here. Get a quick reminder. 1 minus 3 is -2. We see that twice. 2 minus 3 is -1. 4 minus 3 is 1. And 7 minus 3 is 4. We have a total here of 0. The reason I'm repeating this is to introduce standard deviation. If we were to try to talk about, hey, we found the mean and we want to talk about a measure of dispersion related to mean, well, score minus mean, sum of 0, if we try to average out those differences, 0 divided by 5 would still be 0. That doesn't get us anywhere. So if we had no negatives, these would not balance out. One way of doing this would be to take the absolute value, but that's not the route we're going. Instead, we're going to square everything. Remember that anything that is a real number squared, you get a non-negative answer. So 4, 4, 1, 1, and 16. Now look at the total. That gives us 9, 10, looks like 26 there, double checking. 18, 22, 26. Yes, that's what we have so far. Score minus mean, all of that squared gives us a total of 26. Now, where we go after that, it depends on whether we have a population, if our data came from a population, or if it came from a sample. As an important side note, this symbol is a lowercase Greek sigma. That's the standard deviation for population. For a sample standard deviation, it's S. So the big thing is after we get the sum of score minus mean squared, we do that for each score, score minus mean, square it, add it all up. Well, for a population, we would divide by the population size. That gives us something called the variance. and then we take the square root. Whereas after we've got our sum here of score minus mean quantity squared, if your data is from a sample, take one away from the sample size and then divide. That gives you the sample variance, followed by taking the square root to get the sample standard deviation. So since I just made up that data, I'm going to show you calculating it for each. So again, if we have a very small population with just 5 individuals, here is our population variance, sigma squared, and then our population standard deviation is sigma. Whereas if our data came from a sample, we're dividing the 26 by 4. That gives us our sample standard, our sample variance, s squared. Taking its square root, we will get s, the sample standard deviation. Notice this could be done all at once. We could for example, for the sample standard deviation, we could type that total, divide by, and then put parentheses around what we're dividing by. Same thing. And one last thing, the data did not need to be in order. If I put in, after clearing this out, the 2 1s, the 2, the 4, and the 7. I'm going to show you a shortcut by pressing stat again, going over to calc and one variable statistics. The shortcut, make sure your instructor is okay with it being used before using it. You may be expected to be able to do things by hand beforehand. So I put stuff in list 1, don't need to change that. Just go down to that calculate row and press enter. There is the mean of 3 that we calculated. And notice that we've got S of X, 2.54 something. I'm not rounding it, I'm just not reading the whole thing. With sigma, 2.28 something. And let's see here if I can scroll back. Okay, 2.54 something for S, the sample standard deviation, versus 2.28, the population standard deviation, depending on where we got the data from. So those match up.